Hey everyone, my name is Tural. Today we are going to talk about designing high-scale event-driven microservices with Azure Cosmos DB. Before getting started, I want to give a brief information about myself. I am the author of Hands-on Microservices with JavaScript book, published by Pact Publishing. I am the only Microsoft MVP from my country in C# and web technologies twice. I am public speaker and I'm the author of Apache Kafka for Distributed Systems course on Udemy, and I have a YouTube channel, Tural Suleymani Tech, where I share my knowledge and also I invite tech giants. And we are having podcasts where we talk about modern software development approach, and we are talking a lot related to software development. What I have prepared for you today, I don't like to have presentations. And actually, I know that software developers learn from the code rather than presentations. That's why before our talk, I've created a GitHub repository called Production Ready DDD EDA Azure. You can find it going to https://github.com, Tural Suleymani, Production Ready DDD EDA Azure. This is our source code. Let's switch to our source code. This is our URL. And I have prepared all the source code for you. You can easily just download and explore our source code. This is not just the source code. I've provided a detailed README file where I explain read-write paths. I'm explaining which design patterns and principles I've used here, and also all the information related to the project, how you can configure it, what type of payload you should send, accept, etc. You have all the information, and plus I have added additional watch and learn section here, which you can easily learn the concepts, most important concepts from these tutorials, which we have the videos in our YouTube channel. Okay, cool. Now a brief regarding to the project. This is a cloud first project. This is a microservice. We have applied domain-driven design, event-driven architecture, clean architecture, design principles, patterns. I have used approximately 30 design patterns in this project. And of course, Azure Cosmos DB will focus completely to Azure Cosmos DB rather than the programming elements, because this session is all about having Azure Cosmos DB behind the scenes, which will help you to scale to infinity. Okay, this is our source code. Let me open this. We have used clean architecture here. But before switching to Azure Cosmos DB part, I want to talk about domain-driven design. Why? Because this project strongly emphasizes using domain-driven design. Why? Because in such type of microservices, especially when you have complex business logic in your applications, you should prefer domain-driven design approach. Domain-driven design is not a design principle. Domain-driven design is a software development approach. It is a software development methodology. And domain-driven design is all about discussing, learning, listening, bringing business value rather than a technology. You can apply domain-driven design to any modern programming language you're using. And why domain-driven design? Because in a complex domain, you need a centralized business knowledge. In a complex business domain, you need to remove gap between your business people and software developers. So the business will live inside your code, and you don't need to maintain a lot of documents in order to understand what's going in your application. And for the newbies, join it to the team, you don't need to provide additional tutorials, I don't know, the documents. Your code is the mirror of your business. Anyone can easily understand, should easily understand the business from your application rather than reading and exploring other resources. Domain-driven design helps you to have zero translation between your business people and developers. Why? When you have translation between these people, you're actually losing some business value. That's why domain-driven design avoids translation and have zero translation between business and software developers. We have actively used domain-driven design with clean architecture here. We have VOE Consulting, Flame Order Management domain. When you go to this project, you see we have order. This is our aggregate route. Domain-driven design by its nature has two main parts, strategic and tactical patterns. From the tactical pattern perspective, you are having aggregates, entities, value objects, modules, repositories, factories, and more. And from the development perspective, for your domain layer, you are actively adding entities, value objects, aggregates, domain events, services to this layer. We have order. This is a classical class, but it is not a DTO. Why? Because it has some sort of business behavior. It is a rich domain model rather than a class that has getterans and setterans. Okay, you see we have cancel. This is a business element. We have mark shipped. This is also a business behavior rather than a class with multiple get and settern properties. Okay, and this domain-driven design approach with aggregate route helps us to raise domain events. In our aggregate route design, let's go to the definition. I have prepared a separate project for you called Flame Domain Common, and here we have all the base classes related to aggregate routes, value objects, entities, etc. Our aggregate route allows you to have events. Why? Because in our business side, we need to understand what's happening, and we will send these events to other services because these other services also need some information, mandatory information regarding to the business processes that happen in our microservice. Okay, in my case, we have cancel. Someone can cancel the order. We are raising a domain event. Someone mark ships. We are also we have mark shipped where we also raise a domain event. Okay, this part, the domain layer, is all about having business components, the real domain elements. You have order. We also have a lot of interesting value objects here. Let me open and show it to you. We have money breakdown. Let's go to it. Let's go to definitions. You see, this is our value object because in domain-driven design, we are actively creating value objects to encapsulate our business inside value objects. Mostly with domain-driven design, we're actively using value objects rather than aggregates and entities. Okay, most of our part, most of the elements, the business processes considered inside our value objects. Cool. Now I want to show you the whole process. What should we expect from our project? We have a client, and client sends requests to our applications. The request flows like this. You can easily find this diagram from our GitHub repository. Go to our github.com Tural Suleymani production ready DDD EDA Azure, and here you can just easily see the right path. You're just opening it like in a Zoom mode. You see the full flow. I'm using a separate third-party application to demonstrate it easily for you. And we have Postman and we have Visual Studio to run and test our application. But before switching to application run, let's understand the full flow. We have a client. It sends, she sends a HTTP request, post request. We have API. API redirects our request to the application layer. In our application layer, we are calling our aggregates. We are applying additional business operations over it. And at the end, we have order repository. Let's switch to the code and see what happens here. When our user sends a request, for example, placing order, we are using CQRS stuff here. We have command handlers, so you see. In this case, our command handler is actively using aggregate with repository. Okay, in order to construct this aggregate, we actually need some sort of entities, value objects. So we are actively applying these value objects here. But the main part here is our customer, our user places a new order. And then our action will return this process because I have implemented a template method pattern here. We have order command handler base. Let's switch to order command handler base. And you see we have provided execute async as an abstract method because we have a framework, a small framework, which we have implemented using template method pattern. And when we get response from this implementation, we are calling our order repository and we are saving all this stuff together. Why? Because this order repository is actually an implementation form of Cosmos DB. So we have Cosmos order repository. We are using transactional batch here. Why? Because when you send a request, you are doing more than one operation. For example, in a transactional context, you may write and update two tables at the same time, which you are creating a transaction. But when the parts of your system is actually a different technologies, like for example, I'm using Entity Framework to store my data, but meanwhile, I want to send information to Apache Kafka. How you can make these two operations a transactional operation. That's why we created Cosmos order repository, which uses a transactional batch. But before diving the transactional batch of Azure Cosmos DB, let's switch to our presentation and understand Azure Cosmos DB partition keys. Why? Because as you see here, we are actively using in this repository, first we're actively using this partition key, okay? Why partition keys? Because choosing partition keys provide high cardinality values. You should use, for example, customer ID, tenant ID, sometimes order ID, device ID as a good choices for your partition keys. Don't use partition keys that doesn't allow you to scale, for example, country names, status, region, which they limit your scaling. For example, is active, true, and false. You will end up with two values. But customer ID, tenant ID, account ID allows me to scale to infinity, let's say, okay? We use values frequently present in queries, and choosing proper partition keys allows you to avoid hot partitions when one partition has a lot of data, but other partitions has a small amount of data, okay? And we should always prefer immutable keys. Now let's switch to our Azure Cosmos DB implementation. Here our repository is using a transactional batch. What is transactional batch? Transactional batch is a feature of Azure Cosmos DB. It allows you to implement mostly in event-driven systems. I mostly apply Azure Cosmos DB's transactional batch feature for event-driven architecture with domain-driven design, which I applied in my GitHub repository. You have more than one operation. You want to have them as an atomic operation, like in a transactional scope. So all operations should succeed or fail. That's the real case where you should use transactional batch. A transactional batch works with only the same partition keys. Don't use different partition keys for your transactional batch. And it supports a single request. You can apply create, update, upsert, delete, replace, and other operations, mostly with patch. And transactional batch improves your performance because it uses least network calls. And this is ideal for outbox pattern implementation. And yes, this requires a good partition key design. In my case, I've configured my partition key. I'm preparing my outbox data with create item. You see, I'm using the batch. our container. This is Azure Cosmos DB. You see, Microsoft Azure Cosmos container. We have a container, and this container has create transactional batch with partition key, which allows me to create a transactional scope. Everything will be in one single request. For example, I have 3 operations. They should succeed together or they should fail together. That's the modern approach for implementing outbox design pattern in modern days. Okay. And here, when I run this stuff, when I create a transactional scope, that's of course not the end of the flow. Let me show you the exact flow. You see, we have order command handler base, which I demonstrated, and we have order repository. And after order repository, we have eventual operations. You see, our Azure Cosmos DB is doing some operation. This is our change feed. I'll talk about change feed also, because the next after transactional batch, we have change feed. Let me just run our application, and using breakpoints, using debugging mode, let's track whole the process in our application, what's going on, and see how easily we can implement event-driven systems, high-scale event-driven systems using Azure Cosmos DB. I have a Postman here. When you configure all stuff regarding to our GitHub repository, you will call order endpoint with the provided payload. You can easily find this payload in our GitHub repository. Just scroll a bit down, and here we are. We have the payload. Just copy and paste. It should work. Okay. Now let's go to our Postman. I am configuring my order ID and sending request. But before sending it, let's add breakpoints. Of course, we have API program. I've used it, not a controller approach. You can replace this with the classical controller or minimal API endpoints. Let's go to implementation, and here we have map post. You see, I'm adding this breakpoint here, sender send, which should send request to our application, place order command handler. Let's add breakpoint, for example, here, and then it should call our template method implementation. Go to definition, and here we are calling our Cosmos DB implementation. And I'm just going to the implementation, and here we have save changes. Okay, let's run and see if everything is working properly or not. Okay, we are sending the request. Okay, cool. So you see, this is our place order command handler. We have accepted this request. We are using our aggregate to instantiate our aggregate root, which should not fail. You see, we have this aggregate root, and then the main flow is in our base class, which should take it and call our save functionality. You see, this is our Cosmos order repository, and we are calling our save functionality. This save functionality will call our transactional batch. This is our transactional batch creation, which should also trigger another Azure Cosmos DB feature. Let's go to the infrastructure layer, and we have change feed. I'm just opening this change feed and adding the breakpoint here, and I will deep dive into details of change feed a bit later. Let's run it. And now everything is good. You see the response. We are getting our response. It means everything is okay. Now we have Cosmos Outbox process marker. I will talk about this marker also. Let's just continue for now. And here we are. We have the data. Okay, everything is good. Now let's switch to Azure Cosmos DB. In our Azure Cosmos DB, just create Cosmos Conf. You can give any name for your database, and you see I have a lot of collections. In our README file, I have added all the details regarding the partition keys for this collections. And now, after successfully running this application, it means everything is okay from our application perspective. Now, let's switch to our Outbox change feed hosted service. Why? Because we have created a separate worker file. Just open the program CS, and you see we have a lot of method extensions which allows us to add the services we want to run in a background mode. Okay, let's go to the definition, and here we have all these extensions. So you see we are configuring our change feed, we are configuring the projection stuff, order projection, summary projection, etc. Now, let's talk about Azure Cosmos DB change feed. Why we need Azure Cosmos DB change feed? As I demonstrated before, in Azure Cosmos DB, we have collections. And in most cases, for event-driven systems, you need to understand what type of data change. And you don't want to pull every time. We have Azure Cosmos DB change feed feature. Now let's switch to our presentation, and this is our change feed. You have a container and you want to listen to this container because you want to understand what's happening inside this container. You want to see the container data as a stream of data because you want to understand what type of data inserted to this container, updated inside this container, and also you want automatically capture information regarding to this data. And this sort of feature is ideal for CQRS read model projections. You can trigger other microservices or workflows, and it doesn't capture delete directly and require least container for multi-instance coordination. That's why we have created a leases container in our Azure Cosmos DB. And how we implemented this feature, it is really easy. We have a separate worker project here. This worker project automatically runs and easily captures all this data regarding to our application. For example, I'm going to our infrastructure. Inside my infrastructure, I have change feed. And in my change feed, I have Outbox change feed hosted service. As you see in this hosted service, I have start and I have handle feature here. For example, dispatch Outbox item. I have called this feature in our handle. So you see, this is our dispatch Outbox item, which we try to publish to Outbox log, and you can do any other operation which we triggered mark processed. Okay, I'm just adding breakpoint here to see if everything is properly working or not. So you see we have handle feature. We are calling this handle feature where, of course, when we run this start, you see this is going to run our functionality. Now I'm going to add another order. Let's send this request. Okay, let's continue. It saves. Okay, and when everything is done, we are calling our dispatch Outbox item here. So this dispatch Outbox item will publish data. So you see we have a publisher. Let me go to implementation of this publisher. This is our service bus publisher, which this service bus will send data to the service bus for other microservices to listen to our information, because we have events, and other microservices are also interested in our events. Okay, that's cool. Let me show you the whole process here. Now our change feed deserialize the data, publish integration event, log publishing, and mark outbox row, which we have all these features inside this try. So you see, our Azure Cosmos DB easily helps us to develop event-driven microservices. You have a cool infrastructure. When you use Azure Cosmos DB, it is NoSQL database. It allows you to scale to infinity. It has auto scaling feature. It has tons of features that supports your cloud first microservices. Okay, you have change feed, you have a transactional batch. All these processes makes your life easy when you develop high scale event driven microservices. You can find more information in our GitHub repository. We have the read path also, because Azure Change Feed also helps us to project data from the read perspective. It is easy for us to aggregate project data. You don't need to focus on the complex queries. Everything is ready when you write your data. Well, that's pretty much all what I wanted to demonstrate today. And I hope to see you in our next Azure Cosmos DB conference. Bye.